Assalamualaikum warahmatullahi wabarakatuh. Welcome to the new topic of Math 3, which is Introduction to Limits. So the first thing we learn in limit is one-sided limit. Let me show you how to do the one-sided limit. So for example, we have the function of fx equal to x plus 1. So that is the straight line here. And let's say that we want to take the limit of f at x equal to 2. So how to do it? Let's focus on x equal to 2. So if you go up here, this is the point, okay? So basically at point f2, your function is equal to 3. However, for one-sided limit, you must check the limit from both sides. In order for the limit to exist, you must check from both sides, and when both sides' limits are the same, therefore the limit will exist. So let's say that the limit of f as x approaches 2. So we say that the limit of f as x approaches 2 is equal to 3. So we can write it as limit of fx as x approaching 2. This is equal to 3. So how can we conclude that it is equal to 3? Because we have checked limit from both sides, from the right hand side and also from the left hand side. Okay, let's check from the right hand side. So as the limit approaching from the right hand side, it is approaching at the point 3. And as the limit approaching from the left hand side, this will also approach to the same number 3. Therefore, we can conclude that as x approaches 2, the limit of fx is equal to 3. Next, let's see example 1. So for example 1, you have a function fx equal to x plus 1, but your x cannot be equal to 2. So we can see here that you have a straight line here, but you have a hole at x equal to 2. So you have a hole here. So from this example, we want to show that a limit does not depend on the function at x equal to 2. Okay, so it does not depend exactly at this point here, but it will describe how the function behaves as the point getting closer, approaching to the line x approaches 2. So let's see here, at the point f2, the function here is undefined because you have a hole here, but as x approaches 2, you have the limit because limit of fx as x approaches 2 is equal to 3. So let us see the reason why the answer is equal to 3. So let's check the limit as x approaches 2 from the right. This is approaching 3, and as x approaching 2 from the left, this is also equal to 3. That's why the limit of fx as x approaches 2 is equal to 3. So let's see example 2. This graph here is not a straight line because you have a jump here, okay? A jump at x equal to 1. So let's see here, do you have the value of f1? Yes, we have it. The value of f1, this is it. This is equal to 3. Okay. But now let's check what is the limit of fx as x approaches 1. So let's see, when the graph is approaching 1 from the right, the answer is equal to 3. Meanwhile, the graph as x approaching 1 from the left, this is equal to 2. Since the value are not the same, we can say that limit of fx as x approaches 1 does not exist. You may use shortcut D and E. Why? Because a limit must be the same from the right hand side and also from the left hand side.